Okay, so as I said in the last class, we were done with covering different aspects of how to write a code. And in the last lecture, we looked at 2D and 3D plots. So that is going, so whatever we covered in the last lecture would be useful every time you use MATLAB and you try to generate some kind of visual. So today we are going to look at another application with the presumption that you know how to write a code. We are going to look at how you can use MATLAB to do different kind of algebraic calculations. But before that, let me talk a bit about the structure of the lab classes. So you guys saw my email, right?
Yep.
So the Mukesh, he had to go back to India, and I did not know until I saw some of your emails, and even then I wasn't sure that what he was doing. But he flew back to India on Monday. His father is apparently critically ill with COVID. He emailed me back last night that he might try to arrange the classes from India virtually, but I'm not very positive on that based on the situation that he is in. So I've talked to our department chair, so we might try to arrange alternate possibilities as well, having someone else to do the lab classes. But at this kind of short notice, we probably won't have anything this week. And hopefully by next Tuesday, we are going to let you guys know what we are going to do. Also, there is a question, what is the time difference? It is 10.5 hours. So India is into the future. So for example, if it is 11 a.m. over here, it's 9:30 p.m. the same day at night. By the way, quick fun fact, India is the only country which has this half an hour difference. So it's based on the time of the year, it's either 9.5 hours or 10.5 hours. With every other country, it's a whole number hour difference from here. Anyway, so it's also unclear to me, as you guys can tell, but I'll try to let you know once we have a clear plan on how to go about it. The good thing for me personally is we are almost done with MATLAB, but we need to figure out how to carry on the lab classes as you move into the next half of the semester when John Verstick teaches you SolidWorks and Excel. Okay, so with that, let's go into our lecture today. As I said, we are going to do different algebraic manipulations with MATLAB. So first, we are going to deal with polynomials, and you know that what is a polynomial? Polynomial is an algebraic expression that has different powers of x. So for example, this can be considered a typical example of a polynomial. So with polynomials, we are going to learn different MATLAB commands that would help you to do different kinds of stuff related to polynomials. And we are going to take each of them and carry out some examples. So let's first look at this first one, which is Polyval. And a good thing for you guys to remember is the name itself of this function would tell you what it is supposed to be for. For example, Polyval, because of this val part, it essentially implies that it would help you evaluate some polynomial. So for example, if we have this polynomial, then using the polyval command, we can figure out the value of this function for different input values of x. So let's see how this works. Okay, so let's walk through the command window for now. But as we know very well by now that whatever we do on the command window, we can also arrange them in a logical order to write a code as well. So let's look at what Polyval does. As I just said, it can find the value of a polynomial, and to find the value, MATLAB first it's to know what is the polynomial. So the first step here is telling MATLAB what is the polynomial. So let's consider this to be the question that we are trying to figure out. So this is the polynomial that's given to you, And we are trying to figure out what would be the value of this polynomial when x is 1. So before we can do that calculation, we need to first tell MATLAB what the polynomial is. So you would do that again in the form of arrays. So when we started out this lecture, we learned that MATLAB always tries to reduce all the problems in the form of array of numbers. And the same philosophy holds true here. To set up a polynomial on MATLAB, you have to generate an array, but the array elements are the different cofactors for the different x terms. And you go from the highest power of x to the lowest power of x. So for example, the cofactor for the highest power of x here is 5. Because highest power of x is x to the power of 5 and the number associated with it is 5. The cofactor for x to the power of 4, which is the next lower power of x, there is no x to the power of 4 term, so it should be 0. The cofactor for x to the power of 3 is again 0 for this polynomial because there is no x cubed term, so 0. The cofactor for x squared is 6, so there goes 6. The cofactor for x to the power of 1 is 7, so we write 7. And the cofactor for x to the power of 0, so x to the power of 0 is 1, so basically 3 is the cofactor for x to the power of 0, so we write 3. So this is how you set up a polynomial into MATLAB. So by telling MATLAB what are the cofactors for the different powers of x starting from the highest power. So once we set this up, then to figure out what would be the value of the polynomial, so value at x1 would be Polyval. And now we are going to follow this syntax, which is over here. So we state the polynomial. P is represents the different cofactors of the polynomial in the form of an array, just like we have set it up here. So P, comma, and then for x, we are going to input in the value of the x for which we are trying to figure out the value of the polynomial. So for this example, we are trying to figure out what would be this polynomial's value for x is equal to 1. So we are going to type in 1. And we are going to press enter. So the value at x is equal to 1 is 21. You can do a very quick check of whether you got it right. So plugging in 1 for the x positions. So this is 5 plus 6, 11, plus 7, 18, plus 3, 21. So it indeed is correct. Okay. So the main thing over here is to be able to tell MATLAB what the value of the polynomial is in terms of the cofactors, and then remembering what would be your command to figure out the value. So let yourself, so basically you need to tell yourself that you have to figure out what the function of that command would be based on the name of the function, because after a while you might get confused because we are going to cover 5 different kinds of functions. So whenever you see the word value, it will tell you that you are basically trying to figure out the value of that function there. Okay, so let's look at a couple of more examples. Okay, so I have a few more examples here. For example, this is the polynomial that you need to set into MATLAB. So of course, over here, the highest power of x is 2, and the cofactor associated with that highest power is 2 as well. So when you set up the polynomial, or you try to tell MATLAB what that polynomial is, here the first cofactor that goes in is 2. The next cofactor is with x to the power of 1, which is -4. And then with x to the power of 0 is 10, so 10 goes over there. So let's look at an example here. So this polynomial is given to us, and there are 2 parts to the question. Find the value of this polynomial at x is equal to 9. So basically find f9, and then plot the polynomial over a certain range of x. Okay, so let's try to do this one. Again, would you guys prefer to work on the command window, or do you want to work on the write a script file for this. Anyone? Script file, a code, or do you want to continue working with the command window?
Do a script file.
Okay. Okay. So the script file should probably have these two parts laid out separately. So
we can look back at it.
Yeah, I understand. So okay, so let's write the script file. So clear all, close all, CLC. Okay, so tell me what should be the first step here.
You have to enter in the P value.
Right, so the different cofactors on the polynomial. So enter the polynomial cofactor or coefficient, whatever you might call it, cofactor information. So let that be P. What would be the first element in that array? Anyone? 1. So the next element is negative 12.1, then 40.59. Okay, after 45.59, what would be the next one?
0.
0. And can you explain why?
Because there's no x squared value.
So you need to make sure that you account for all the missing terms as well. And for a missing term, we just plug in 0, and then negative 71.95, and then 35.88. So this sets up the polynomial. The next step for us is to figure out what is the value of f9. So calculate polynomial for x is equal to 9. So let that output be called f9. What would be the command for that? It's polyval, right? So polyval, what should be the first input over there?
P.
Just P, and then
9.
for x, which is in this case is 9. Okay. So we get this part done. So hopefully this is part A. Now let's think about part B. So which is about plotting the polynomial over a range of x. So what would be your first step here? You have already told MATLAB what the polynomial is, right? Now you're trying to evaluate that polynomial. To plot the polynomial, you first have to get the value of the polynomial over that range of x. So basically the idea is to figure out the values of the polynomial over that range of x. But to do that, what would be the next step here on this code?
Could we do b equals negative 1.5 colon, and then, I don't know, let's say 0.1, and then colon 7.5?
You're right on the right-hand side, but why are you assigning this? P is supposed to be just of the polynomial cofactors, right?
Oh, right. Yeah. I was thinking b as in like Bravo.
Okay, I see. So basically, we can just write it as x. We don't need to another different variable. So this is the range of x that you are setting out. Make sense? Okay, so this is the range of, so basically what we just did is we have to find the polynomial over that range of x. So let's set that range to MATLAB. The next thing to figure out is the value of the polynomial over that range of x. So let's see how we can do that. So if those values are named as p values, or let's call it P data, because P value has a separate connotation in statistics. Anyway, so P data is polyval of that polynomial P, which has already been set up in line number 6. But now you are trying to evaluate this polynomial P over that range of X. So it is sufficient if you just type in X, because you have already set up that X to include a number of points over that range. But this does not end our task. We have just calculated the value of the polynomial over that range, but we have to plot it as well. So let's see how to do that. So to get the plot, what should be the, so we know the syntax for plot XY. So what would come in for X here?
X.
Okay.
P
X.
data.
Oh yeah. Mm.
Should it be X or P data?
Shouldn't P data be in the Y component?
To the Y, right? So P data is the value that you are plotting. So that's in the Y axis. You're right. So X P data, and we should generate something. So let's set this. Let's see what we get. Why did my directory go? So let's fix this here. Okay, guys, I need to make sure that the directory is fine, and this can happen with your computers as well. Sometimes MATLAB just tries to pick something else as the directory. So if I so let's try and save this one here. So do you guys get what the problem that I'm facing here? So when I'm trying to save this code, it automatically tries to get something entirely different than what I want. And this is not where you guys would want to save your files, because even for example, when you are writing your test, you need to have the files available to you, right? So make sure that whenever you do this, you save the files at the correct MATLAB folder. Okay, so let's try and do that. Documents, MATLAB. This looks like where we have been saving our files, fall 2020. So let's do that. This is like 9. Code 1. Okay. Now you can still see that the current directory is something else. So when I try to run this, it still worked. So all good. That's fine. So make sure that you save your files in the correct spot. Anyways, okay. So this is how the plot looks like. But of course, we know that we can make it look prettier. For example, instead of along with XP data, if we type something like this, the plot would become, as we know, red. And this is, for this one, you can actually go back and look at the lecture that we had in the last class. So for example, if we want to make the plot look thicker, we can do line width and then maybe use a trial number and then save this and then run it again. So you can iterate on how you want your visual to look like. Okay, any question on this one? So this shows that you can use this syntax polyval px even when x is a range of values and not a single discrete value. But in general, this second placeholder is for the value of the input value of x for which you are trying to figure out the value of the polynomial. And to plot a polynomial, you have to figure out its value at all the different points over that range to plot it. Okay. So I have the screenshot of my code here. Any question on this one? Okay, so let's move on. So we just covered polyval. The next command that we want to do is something called roots. And the name itself would suggest you what it is meant for. So imagine you have a polynomial. Using the roots command, you can figure out the roots of that polynomial. And by roots, of course, you guys have done algebra before. So those are the values of x for which the polynomial would be 0. So let's see an example for this. Okay, so let's keep on working with the same polynomial. So to find the roots of a polynomial, the first thing that you are going to do is to tell MATLAB what the polynomial is, and we are working with the same polynomial. So this is the polynomial. Now, the syntax for the roots command is just this. So once MATLAB knows what the polynomial is, if you type roots bracket that polynomial, it would give you the values of x for which that polynomial is going to reduce to 0. So let's try that. R is equal to roots p. So these are the values of x for which that polynomial is going to be 0. Now, there is a quick way to check if this is indeed the case. So let's try this. And let's type polyval p. And instead of for the place value for x, I type in one of the roots. So can anyone tell me what should be the answer for this?
0.
0, right? Because it is a root. If we place the root, the value of that root into the polynomial, the answer should be 0. And we don't really get 0, but we get something which is very close to 0. The reason being, everything over here with MATLAB, it's a numerical solution. So you always don't end up getting something close to 0, but it would be 0. So let's try another one here. So let's look at this one. But the imaginary part is actually could be considered 0. So let's just type in that part, the real part. And see, it is close to 0, but it is not necessarily 0. And the reason for this is it's a numerical scheme. So it always is going to give you approximate numbers. So I have this example here, and the screenshot actually shows you this work, how to get the roots. Okay, so this is pretty simple. So you just type in the polynomial and you do you use roots bracket p and you get the roots. So this kind of questions for the final exam might be small 2-point questions where I just ask you to write something on the command window and take a screenshot of your work. So you need to remember the different functionalities that you have available on MATLAB to get different types of this kind of algebraic things done. Okay, so this was the second command. Let's move into the third one, which is poly. And what poly does is basically find the coefficients of a polynomial if the roots are known. So imagine that the roots are known to you. You are trying to figure out what the polynomial is, such that the roots are those particular values. So let's again try this example. And we knew that the different roots, so if they are called roots x, you get that with this command roots and then p. Now, if having the roots and then using the poly command gives you back the original polynomial, then if you can write something like this, poly roots x, what should be the output?
P.
It should give back those cofactors that you originally started out with, right? Because these are the roots for that polynomial. So let's see if we get that. So 1, negative 12.1, 40.59, negative 0.0, negative 71.95, and 35.88. So this checks out your work. So once you know the roots, if you use poly on the roots, you get back the polynomial for which those roots are for, okay? So this is just an example, well, the very same example over here. So these are just very small things that I want you guys to remember, particularly for small 2-point questions for the exams, but in the long scheme of things, when you are using MATLAB later on for other courses, just knowing that these are the different things that you can do on MATLAB would help you to solve problems. Okay, so the next thing that we want to do is how to add, subtract, and multiply different polynomials. So addition and subtraction is really easy. Because you just use the addition symbol and the subtraction symbol. The difficult one is or not the difficult one, but you have a special command for the multiplication of polynomials. So let's solve this example. And again, let's write a script for this. So we have to first set up these two polynomials and then get outputs for f1 plus f2, f1 minus f2, and f1 multiplied f2. So let's write the script. You're all, close all CLC. So step 1 is introducing the polynomials to MATLAB. So the first polynomial is f1. Let's call that f1. And the cofactor for the highest power of x over there is 3. Then x to the factor for x to the power of 5 is 15. What is the next cofactor? Anyone?
0.
0.
Yeah, so don't miss out on that. This is really easy, but missing out on these things might lose you 2 or 3 points on the test. So 0, negative 10, negative 3, plus 15, negative 40. F2 is 3, then there is no x squared, so 0 for that. Then negative 2, then negative 6. Okay, so now let's do part A, which is addition of polynomials. So part A is just f1 plus f2, and that should be sufficient. Let's do a double check. Let's save this for now. Again, it goes back to so fall 2020, lecture 9, code 2. Okay, so if I save this, we get an error. And why is that error? it says that the matrix dimensions must agree. Okay. So I have not entirely covered this, but can you guys take a guess and tell me how can we correct this?
Can you add zeros at the beginning of F2?
Yeah, that's correct. So once you are writing the same two different polynomials in the same code, you need to have the same kind of unit system. In this case, it should have same number of powers of x. So you just starting out with different number of cofactors would confuse MATLAB because it now doesn't know what is the highest power of x. So over here, we started from x to the power of 6. So we have to insert a 0 for x to the power of 6, a 0 for x to the power of 5, a 0 for x to the power of 4, and then we have 3 for x to the power of 3. So let's just do a double check of how many terms are there. So 1, 2, 3, 4, 5, 6, 7 in F1, 1, 2, 3, 4, 5, 6, 7 in F2. So make sure that whatever is the highest order polynomial, write its terms first, and then accordingly figure out what would be the 0 terms in the smaller polynomials. Okay, so let's save this and then run this. So now you get the addition, but it doesn't really give you a polynomial form addition. It just gives you the cofactors of that sum. So for example, here we had negative 10x cubed and 3x cubed. So the sum should have a negative 7x cubed. So that's this term over here. So you can just double check your work by summing them up on your own. But in general, the addition is quite easy. You just use this addition symbol as long as the orders of the polynomials are set correctly. So let's now go to the second part. So part B is subtraction of polynomials. And for that is again just F1 minus F2, and that is sufficient. Now part C is multiplication of polynomials. Now, for that one, we cannot just do a multiplication sign. There is a separate command for that because the cofactors should be multiplied to each of them separately. So it's slightly different than using the multiplication sign. So the command for that is conv, and then you type out the two polynomials, which in this case is F1, F2. Okay, so let's save this and run this. So these first two parts are rather easy. Let's think about the third part. Just do a quick calculation in your head and tell me what should be the highest power of x when you multiply F1 and F2.
Nine.
So accordingly, when you get that product out, there should be 9 plus 1 term. So there would be 1 term for 10. So for example, when we plugged in x to the power, this polynomial, where the highest power of x was 6, you basically have to input 7 terms because there is 1 extra term for x to the power of 0. So if it is a polynomial of order 9, there should be 10 terms over here. So this is how you double check your work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But we did not get 10 terms. We got something else. So what else is going on here? Anyone? You get what my question is? So basically we are trying to get the multiplication of F1 and F2. And once you get the product, you get the cofactors of that polynomial product. So here we started out with some zeros, and then we ended up getting these numbers. So what is going on here?
Since we had to put in zeros for the x to the 6th term on F2, it's reading like the x to the 12th and x to the 11th and x to the 10th.
Right. So these 3 zeros, they're not really accounting for much, right? So essentially you start from this term. So it might be easier for you to count them from this side. So this is the term for x to the power of 0, then x to the power of 1, then x to the power of 2, x to the power of 3, x to the power of 4, 5, 6, 7, 8, 9. So you get real terms till x to the power of 9. These 3 terms, they don't really change the nature of your polynomial or the highest order of your polynomial. Okay, so make sure that you understand these nuances, because again, MATLAB thinks just in terms of array elements. And while trying to write a code, while you develop your algorithm, you need to think in terms of arrays as well. Otherwise, things can get messy very soon. Okay, so just remember that this conf command is for you to multiply different polynomials. Okay, any question on this one? Yeah, I have the screenshot for this code. So this is the only thing that I wanted to show for addition, subtraction, and multiplication. Let's look at another thing now. And now we are gradually going into the domain of calculus. So polyder is a command where you basically take the first derivative of that polynomial. So to give you a quick example, when I use polyder, again, the part there should indicate to you that this has got something to do with derivatives. So that might help you remember what this particular command is supposed to be for. But anyway, so when you have a polynomial, 3x squared minus 2x plus 4, if you are using a polyder command on this, you basically are going to differentiate this polynomial with respect to x to get the differential. Okay, so let's try out this particular example. But before that, the syntax for polyder is basically this. So polyder of p, once p is known to MATLAB, where p is a polynomial with all the cofactors in the form of an array, this output would give the differential. And polyder AB, here A and B are the product of the 2 polynomials, and a polyder of AB would give you the derivative of the product of those 2 polynomials. So let's rather look at some examples here. So we have these 2 polynomials, f1 and f2. The questions are, find the derivative of f1, find the derivative of f2, and then find the derivative of f1 multiplied by f2. So I already have the screenshot here, so maybe we can just go through this one. So the first step again is to tell MATLAB what the 2 polynomials are, and we achieve that with these 2 lines. Now the first part of the question is find the derivative of f1. So you just write polyder f1. Second step is find the derivative of f2, so polyder f2. And the third step is find the derivative of the product of those 2 polynomials. So that is polyder f1 comma f2. So just remember the syntax, and let's still do a quick computation with the first one. So let's try f1 is 3, negative 2, 4. Okay, let's try to figure out what should be the derivative of this particular function. So that is part A as per this question, polyder f1. But before I press enter, can anyone tell me what would be your output?
6x minus 2.
6x minus 2. But it would show the output in the form of the polynomial. So what should be that output?
6 negative 2.
So make sure that whatever you get out of your code makes sense, because you already know the mathematics. And MATLAB is nothing but a tool at the end of the day. to solve your mathematics. Okay, so that's this first three parts. Then the fourth part is find the value of the polynomial, which is actually the derivative at x is equal to 5. So let's see how we do that. So here we are working with f2. So f2 is 1, 0, and why is it 1, 0, and 5? Yeah, so 1 for x squared and 0 for x to the power of 1, so just x, and then 5 for x to the power of 0. Now the question is find first the derivative of this polynomial, and we know that we can do that by writing, so let that be f2 der. We know that if we do poly der of f2, we get that derivative, so which is 2x. So basically 2 for x to the power of 1 and 0 for x to the power of 0. The question now asks us to figure out what is the value of the derivative at x is equal to 5. So how do I do that? We know that to find values of any polynomial, the command that we use would be polyval. So if I write polyval, then f2 der, because that's the polynomial that we are trying to find the value for. But now we are trying to find the value when x is equal to 5 for that polynomial. So this is the output. So basically, you can do a quick calculation in your head. So the first derivative of f2 is 2x. And what is the value of 2x at x is equal to 5? That is 10. So that's the 10 output. So once you get used to using this commands, it might be very easy for you. But right now, the actual calculation part is easy to do in your head. The trickier thing, at least to me, was figuring out which particular command to use at each step, because they all sound very similar. But make sure it makes sense, whatever numbers you get, based on the calculations that you do on the side. Okay, any question on this one? Just like the screenshot that I have over here, you don't really need to have a separate step for this. You can as well directly plug in that polynomial inside the argument for polyval. So that's fine as well. But I try to break it up into different steps because that might help you to understand what are the different things that are going on. Okay, any question on this one? Okay, so that's what I wanted to cover for polynomials. Now for curve fitting, it's also dealing with polynomials, but now you are basically trying to figure out, supposedly you have a number of data points, a number of xy coordinates on the xy plane, and you are trying to figure out what is the best possible curve to pass through all those points. So let me give you a very quick example of that. So suppose these are the 1, 2, 3, 4, 5, 6, 7 data points that you are working with. And you are trying to generate a curve that looks like this. So basically you are trying to generate a curve that passes through all those 7 data points. Now before we solve this example, let me ask you a question. Suppose you have 3 data points. Listen to me carefully. So you have the xy plane, you have 3 data points. What is the simplest possible polynomial curve that can pass through 3 data points? So we have 3 data points, and we are trying to figure out what is the polynomial. Suppose ax to the power of n plus bx to the power of n minus 1 plus dot, 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 dot. Here I'm typing it out just to, because we don't have a blackboard anymore. I'm not trying to do any kind of computation on MATLAB right now. So 3 data points. what is the simplest polynomial of this form that would be able to pass through all those data points? Should it be a cubic polynomial? Should it be a quadratic polynomial? Should it be something just like some ax over b, like 5x plus 3 or something like that? So what is the simplest polynomial that can pass through 3 data points?
Would it be a parabola?
A parabola. Do you remember the equation of a parabola?
Quadratic.
Quadratic, right? So a quadratic equation moves like this. So the simplest curve that can pass through 3 data points is a quadratic polynomial. And what is the highest power in a quadratic polynomial? 2. So this is what I explain over here. Read through it later on. But if you have 3 data points, the simplest polynomial that can pass through all 3 of them would be a 3 minus 1 second order polynomial. Similarly, if we have 7 data points, the simplest polynomial that will pass through all 7 of those points is 7 minus 1 sixth order polynomial. Okay? So that's what I try to explain over here. But remember this particular statement. When n data points are given to you, it is always possible to write a polynomial of degree n minus 1 that would pass through all those points. So if you have 3 data points, write a quadratic polynomial that would be able to pass through all the data points. If you have, as in this example, 7 points, then the polynomial order that should pass through all of them is 7 minus 1, 6. So we can again revisit this concept in the next lecture, but make sure that you understand this because there would be a question on this in the final exam. Okay? So I think we are already close to time, but let me just run you through this example and we might have to again come back to this particular one. So we are trying to generate a polynomial that is going to pass through all these 7 data points. And the function that we are going to learn for this is polyfit. So the syntax is very easy. Here you have the syntax, polyfit x, y, n, where x and y are the given data points to you and n is the order of the polynomial that you are trying to figure out. So for example, this particular example had 7 data points. So the polyfit command for this should be polyfit x, y after you have set up x and y into MATLAB. And then we just learned that for a curve to pass through all 7 data points, the simplest order is when it has an order of 6. So that is the 6 that goes in there. So you're going to get a plot like this, but let's stop here, and we will need more time to invest on this problem because this definitely is going to be there on the test. So we are going to pick this up from next week, and the homework that I have due from this lecture, that is also based on this last concept that we are going to learn. So I'll make the homework due the following week. So let's pick this up from Tuesday from CurveFitting. Any question? Okay, so since we are not going to have the lab classes, and I know that you guys have some homeworks due on September 28th, and then which is next Monday, and then the following Monday, October 5th. So if you have any questions, I won't be able to arrange the lab classes because I have other schedules during those time slots. So just email me or stop by my office. I'll try to help you guys. Okay. So that's it for today. I'll see you on Tuesday.